I want you to start with something very close and very human, something that requires no formulas or prior knowledge, just being here, right now, with your body occupying a specific place and the world silently organizing itself around you. Everything you perceive is born from that point, from your height, from the distance your steps can cover, from the time it takes your body to move from one place to another. Without realizing it, your mind turns that position into the reference center for everything else. Not because it believes you are special, but because that is how conscious experience works. From there arises a powerful and persistent sensation, the feeling of being at the center of something important. Everything happens around you. Everything has a size relative to you. Everything acquires meaning based on your position. The room is larger than your body. The house is larger than the room. The street is larger than the house. The neighborhood is larger than the street. And that progressive growth feels logical, orderly, almost reassuring. Nothing jumps abruptly. Nothing breaks the scale. Everything feels continuous and understandable. Within that logic, the earth feels immense. Not because you have measured it or seen it whole with your own eyes, but because it is the ultimate stage of everything you have lived. Everything you know happens here. Your memories, your affections, your fears, your projects, the stories you were told and the ones you will tell, everything takes place on this ground. The earth is not just a physical object to your mind. It is the container of everything that matters, and your brain effortlessly blends the emotional with the spatial, so that what matters begins to feel large, and what is large begins to feel central. You never see the entire planet. You see fragments, landscapes, horizons, cities, mountains, coasts. But your mind does what it always does. It joins the pieces and builds a solid, continuous image, an extensive surface that seems never ending. The earth thus becomes something vast, dominant, almost absolute, because nothing in your everyday experience competes with it in size. There is no larger object with which you can compare it directly. There is no contrast that reduces it. This is where the trap begins. A very human trap. Your brain is not designed to understand extreme scales. It is designed to survive within a very narrow range of sizes, distances, and times. It is made to move through spaces traversed on foot, to react to nearby dangers, to orient itself in a world where a few kilometers were already a great journey. Everything outside that range does not feel real, even if you know it exists. You can learn it, memorize it, repeat it, but you do not integrate it deeply. You do not feel it. That is why the earth not only seems large, it also seems stable, permanent, almost eternal. The mountains have been there your entire life. The oceans have always existed for you. The continents do not move before your eyes. The ground beneath your feet conveys a constant sense of firmness. That stability is interpreted as importance. What does not change seems fundamental, and what lasts seems to occupy a central place in reality. But that permanence is only an illusion of temporal scale. What seems eternal on a human lifetime is ephemeral on a planetary scale. And what seems solid on a planetary scale is fragile on a cosmic scale. The earth changes, shifts, transforms, and recycles endlessly. It just does so at rhythms your perception does not register. Your mind confuses slowness with eternity, and stillness with centrality, because it has no other reference. The same happens with motion. You feel it when you walk, when you run, when you stop, when you turn your head. But you do not feel the earth spinning at more than 1,000 kilometers per hour. You do not feel the planet moving around the sun. You do not feel the sun moving within a galaxy that itself moves within an even larger structure. All of that happens, but there is no direct signal to confirm it in your body. So your brain chooses a comfortable reference. The ground seems motionless, the sky seems to turn, and you seem to be still at the center of everything. That perception was sufficient for thousands of years. We did not need to know the true size of the universe to live. We needed a stable, manageable, predictable world, and the Earth fulfilled that role perfectly. The problem appears when we extend that logic beyond its natural domain, when we use everyday scale to interpret a reality that does not work with smoothness or continuity. The universe does not grow little by little. It does not respect human scales. It operates through brutal jumps of size and distance, changes so large they do not fit within our intuition. And yet, we keep using the same mental tool, the same everyday scale, to try to understand something far beyond our natural perceptual capacities. That is why, even when you know that the Earth is not the center of the universe, you still feel it as if it were. Intellectual knowledge does not dismantle intuition by itself. You can repeat that we are small, but you still see the horizon stretching out. You still see the sky covering everything. You still live as if the stage were immense and stable. This is not ignorance or arrogance. It is familiarity. The Earth is the greatest emotional object of your life, and that weighs more than any number. Before beginning to reduce it, before comparing it, before turning it into a point, it is necessary to recognize this perceptual trap, to accept that the way you feel the size of the world is not a reliable guide beyond your immediate surroundings. Not because you are wrong, but because your mind was never designed for anything else. When you accept that, something changes. You stop defending the Earth's greatness from sensation and begin to suspect that perhaps what seemed enormous was only so because you had never stepped far enough away, and that stepping away is not physical, it is mental. It is a change of perspective that is only just beginning. From here on, contrast will begin to do its work. The Earth will not lose its value, but it will begin to lose its false centrality. It will not cease to be home, but it will stop feeling like the main stage of the universe. And only then, when intuition begins to give way, are you ready to take the next step and truly begin to move away. I want us now to do something you almost never do, not because it is complicated, but because it is not natural to the human mind. I want you to begin to look at yourself from the outside without ceasing to be present. You keep breathing, you keep occupying that specific place, but your gaze no longer remains trapped in your body and begins to separate slowly, as if you were taking a step back without moving physically. Imagine the room you are in, not as you normally live it, but as a complete space, with clear limits, with walls that enclose everything that exists for you right now. During the day, your mind does not think of the room as an object. It is simply the background of your experience. But now observe it whole, all at once, as if you were not inside it, but just outside, looking down from an impossible angle. That first gesture is already an important mental leap, because until now, everything was organized around you, and suddenly you become just one part of the scene. The room stops being infinite and becomes something bounded, manageable, complete. It is no longer the world. It is an object within another, larger frame. Now take one more step, not physical, but mental. The room is inside a house you no longer see from within, but as an entire structure, with a roof, with exterior walls, with a specific size that fits perfectly within your imagined field of view. What a moment ago felt large begins to feel small without losing its reality. The house, in turn, is inside a street, the street inside a neighborhood, the neighborhood inside a city. And here, something interesting happens, because your mind begins to feel a slight discomfort. It is no longer so easy to hold a complete image. Scale begins to demand additional effort. Direct experience is no longer enough. Now you have to imagine. That effort marks the exact point at which you leave everyday perception and enter perception by scale. You are not seeing more details. You are seeing fewer, but you are understanding more. The city from the outside is no longer a set of streets you walk through. It is a shape, a blot, an organization seen as a whole. Houses stop mattering. People disappear. What matters now is the pattern. Without realizing it, you have learned a fundamental rule of distancing. The farther away you get, the fewer details survive. But the clearer the relationships between things become. Now continue to move away. The city is inside a region, the region inside a country, the country inside a continent, and here language begins to fail. You can no longer rely on personal memories or direct experiences. You depend on maps, representations, abstract mental images. Your mind notices that it is crossing a boundary that is not physical, but cognitive. The moment when the world stops feeling lived and begins to feel thought. From this distance, the continent is no longer a place you traverse. It is a shape floating on a curved surface. The curvature begins to suggest itself, and your brain is not accustomed to handling it, because in everyday life, almost nothing curves in that way. The Earth begins to appear not as ground, but as an object. And now take the key leap. Imagine moving far enough away to see the entire planet for the first time, not from a familiar image, but as a conscious mental exercise. A sphere suspended in the void, with no up or down, no privileged center, just a round body illuminated by a star. Here, something profound happens. Everything that was large a moment ago now fits within a single glance. The room, the house, the city, the oceans, the mountains, the deserts. Everything is there, complete, closed, finite. The Earth ceases to be the infinite background of your life and becomes an object among other possible objects. It has not lost its value, but it has lost its central position. This is the first great real distancing, and it is not only a matter of distance, it is a change of mental category. Until now, your mind worked by immersion. You were inside everything. Now it works by observation. You are outside, looking, and that simple change completely alters your relationship with size. The Earth no longer feels immense because you have nothing to compare it with. Now it feels complete because, for the first time, it has an edge. That edge is uncomfortable for everyday intuition because it reveals something daily experience hides. That even what seems limitless from within becomes clearly limited from without. This exercise is not based on numbers or technical data. It is based on training the mind to accept jumps that are not gradual or smooth, but discrete and abrupt to intuition. This is the heart of the idea of scale as a mental jump. You do not advance little by little toward understanding. You advance by breaking previous images and replacing them with others that are broader, less comfortable, more abstract. The room does not grow until it becomes a planet. It disappears as a reference and is replaced by something completely different. The Earth is not a large room. It is another category of object. Here, the sense of centrality truly begins to weaken. Not because someone tells you the Earth is not important, but because you yourself begin to see it as one thing among things, rather than as the absolute stage. This first distancing is the hardest, precisely because it breaks emotional identification, but it is also profoundly liberating. because it teaches you that changing perspective does not eliminate reality. It only reorganizes it. The room still exists, your life still happens, but they no longer occupy the entire field of the possible. Learning to look from the outside is accepting that everyday scale is not the definitive frame of the universe. It is simply the frame in which we evolved, useful and necessary, but limited. And once you make this first jump, once you manage to hold the image of the entire planet without immediately returning to your original position, something becomes clear. If the Earth can look so different just by stepping a little farther away than usual, then whatever comes next will not be a simple enlargement. It will be an even deeper transformation. Imagine for a moment that you begin to rise slowly, not suddenly, not with the violence of a launch, but as if distance were gently expanding beneath your feet. First, nearby details disappear, then roads, then cities, and suddenly the horizon ceases to be a distant line and becomes a visible curve. At that point, something very specific happens in your mind. The Earth begins to stop feeling like ground and starts feeling like an object. From above, even before truly entering space, the planet no longer presents itself as an infinite stage, but as a closed, complete, limited surface. Continents, which from within seem endless, shrink into large, recognizable shapes, patches of color that are no longer traversed but observed. Oceans, which seemed boundless, cease to be abysses and become continuous expanses of blue, dominant but contained, bounded by clear edges. Nothing is lost, but everything is compressed. Here a new and disconcerting sensation appears, that of seeing something large but not immense, something important but not infinite. The Earth begins to fit entirely within a single glance, and that simple fact already changes your relationship to its size. When something can be seen whole, when it has a clear outline, it stops feeling limitless. It stops imposing itself as an absolute background and becomes one thing among other possible things. One of the most striking changes occurs when you notice the atmosphere. From within, air has no form, no edge, no thickness. It is simply the medium in which you exist. But from above, even at relatively close distances, the atmosphere appears as what it truly is: an extremely thin layer, a delicate film enveloping the planet. It is not a thick shield or a solid barrier. It is an almost imperceptible band that separates life from the void. That detail often goes unnoticed until it is seen from the outside. The Earth is not a solid sphere with air around it. It is a nearly naked sphere protected by a fragile skin. Everything you breathe, everything that regulates temperature, everything that makes life possible is contained in a layer so thin that compared with the size of the planet, it seems barely a sigh. Here the planet begins to look small, not because it has yet been compared with stars or galaxies, but because its fragility becomes evident. What seemed solid and eternal from within reveals its vulnerability from above. The Earth does not shrink by distance. It shrinks by context. By seeing it whole, by seeing it as a closed system, you begin to sense that it is not an infinite world, but a finite and delicate structure. The continents no longer dominate the scene. Water occupies most of the surface, and life, including human life, is reduced to an even thinner layer atop that delicate atmosphere. Everything that happens, every history, all biological and cultural complexity, is compressed into a microscopic region compared with the whole. There is no need to go into deep space to feel this. It is enough to move far enough away to see the edge. That edge is crucial. The Earth's edge is what makes it manageable for the mind. As long as there is no edge, intuition keeps believing in the infinite. When the edge appears, when the sphere closes in on itself, the idea of greatness begins to change shape. The Earth stops being everything and becomes something. This point of view does not diminish the planet, it redefines it. The Earth remains complex, rich, extraordinary, but it no longer imposes itself as the natural center of reality. It begins to be seen as a specific system, with clear limits, with very precise conditions that allow what exists to exist. And those limits are so finely tuned that any minimal variation would put them at risk. That is why, even before thinking about the universe, even before comparing it with stars or galaxies, the planet already begins to look small from above. Small not in the sense of insignificant, but in the sense of finite. It is not an unlimited stage, it is an island surrounded by emptiness, protected by an almost invisible skin, sustaining all its diversity within an extremely thin band. When you manage to hold this image, when you can see the Earth whole without immediately snapping back to your everyday perspective, something rearranges itself in the way you think. The planet no longer feels immense by default. It begins to feel precious because of how improbable it is, valuable because of how delicate it is, important not because of its size, but because of what it contains. And this is a quiet but profound transition, because from this point on, the question stops being how big the Earth is and starts being how exposed it is. Scale no longer protects the illusion of centrality. Now it introduces the idea of fragility. And that fragility, once seen from above, cannot be forgotten. We have not yet compared the Earth with anything larger. We have not yet truly gone out into space. And yet, simply by lifting our gaze and closing the planet's outline, the sense of size has already changed. The world that seemed infinite from within now fits entirely inside your imagination. And that is the exact moment when the idea of smallness begins to take shape. Now take one more step, not toward the abstract or the distant just yet, but just one step outside the house into the immediate neighborhood, because this is where intuition begins to take its first serious blows, and where the Earth starts to lose its apparent greatness without drama or exaggeration, simply through direct comparison. Imagine that the Earth is no longer alone in your mind, and that beside it appears the moon, that familiar object you have always seen lighting the nights, marking rhythms, seeming almost like a natural part of the terrestrial landscape. But now look at it not as light or symbol, but as a physical body, as a sphere placed next to the planet. In that instant, something disconcerting happens. The moon stops feeling important and begins to look small, not out of disdain, but out of a proportion, because it fits several times inside the Earth, and because its emotional size deflates once it becomes a measurable object. Here, the first correction of scale appears, gentle but clear. The Earth is larger than the moon, yes, but not in a crushing way, not like a giant facing a grain of sand, but like one body somewhat larger than another of relatively similar size. Two modest spheres floating together in the void. And then comes the detail that is almost always hidden, the real distance between them. When that distance is respected, when it is not compressed to make the image comfortable, something breaks in intuition. Because between the Earth and the moon, there is an absurd amount of empty space, so much that all the planets of the solar system could be lined up between them with room to spare, and there would still be empty space left over. That emptiness begins to impose itself as the protagonist. Until now, emptiness was a vague idea, something mentioned but not felt. Here it starts to feel like the norm, like the dominant condition. Between two bodies we perceive as close there is a silent abyss, without air, without references, without anything to accompany the distance. Space is not full of things, it is full of separation. Now widen the field a little more and let the neighboring planets appear. Mars, for example, that world so often presented as a destination, as an alternative, as a possible reflection of Earth. When you place them side by side, the difference in size is not radical. Mars is smaller, but not humiliatingly so. They are comparable. Two rocky spheres, two solid worlds belonging to the same basic family. And yet, distance once again dominates the scene. Because between Earth and Mars, there is no stable closeness. There is a vast space that constantly stretches and contracts, due to the motion of both planets, a void that turns any journey into an extreme ordeal. Here, the neighborhood stops feeling like a district and begins to feel like a desert in which objects do not cluster but float in isolation, separated by stretches of nothingness that do not match our everyday experience. Now look toward Venus, so similar in size to Earth that for a long time it was considered its twin. Seeing them together, further, weakens the illusion of uniqueness, because Earth ceases to be exceptional in form and basic scale, and becomes one among several similar rocky spheres, each with its own history, each with different conditions, each occupying a specific place in a much larger system that does not revolve around any one of them in particular. And then the giants arrive. Jupiter enters the scene, and with it comes the first truly crushing humiliation. Place the Earth next to Jupiter and watch what happens in your mind. The planet that until recently seemed dominant shrinks into a relatively small point, something that could disappear without a trace inside the volume of the gas giant. Jupiter is not just larger, it is disproportionately larger, so much so that it could contain thousands of Earths without effort, and still it would not be a star, not something exceptional on a cosmic scale, just the largest planet of an ordinary system. Here comparison allows no escape. The Earth is not large. It only seemed so because there was no proper reference. Faced with the giants, it loses visual weight, loses presence, loses centrality. And yet Jupiter is not the center of anything. It is just another object within a system that is itself dominated by enormous distances. Because now look at the solar system as a whole, respecting real proportions, and you will notice something that deeply unsettles intuition. The planets are not packed together. They do not form a compact, orderly family as they are often shown in educational diagrams. They are scattered, isolated, separated by immense voids. Most of the solar system is not occupied by planets or matter. It is occupied by nothing. This emptiness is the hardest lesson to accept. We are used to thinking of space as something full, dynamic, populated. But even in our closest environment, what dominates is not presence, but separation. Bodies are exceptions. Emptiness is the rule. Closeness is an illusion created by diagrams and comfortable representations. The Earth begins to look small not only because of its relative size, but because of its isolation. It is not surrounded by accessible worlds or close neighbors. It is suspended in a vast silence where each object occupies a solitary, distant place. The sense of centrality weakens not through attack or contempt, but through context, because honest comparison makes any defense unnecessary. These are the first cosmic humiliations, not as degradation, but as an adjustment of scale. The Earth does not disappear. It does not lose value, but it ceases to be dominant. It becomes what it always was. One more planet, modest in size, surrounded by larger bodies, separated by enormous distances, floating in a void that has no regard for our intuition. We have not yet left the solar system. We are still at home, and yet the Earth already feels contained, limited, clearly not central. And when that feeling settles in, when the mind stops resisting, it becomes clear that what comes next will not be a surprise. It will be the inevitable consequence of continuing to move away. I want you to imagine that we take the entire solar system and place it inside an imaginary sphere whose radius reaches the orbit of Neptune, out to that edge where the domain of the planets nearly ends and the cold of interstellar space begins. Now think about something deeply unintuitive. If you added up the volume of the sun, all the planets, all the moons, asteroids, comets, and chunks of rock, everything solid and gaseous inside, it would occupy only a tiny fraction of that sphere, little more than a spark lost inside a giant balloon that is almost completely empty. From afar, the solar system does not look like a model full of colorful balls. It looks like a vast desert where there is almost nothing, a desert with just a few scattered rocks and a bonfire at the center. And yet our attention is almost always focused on those few points. If you linger for a moment on that image, you begin to notice who truly rules this landscape. The star at the center is not just a pleasant source of light. It is the absolute master of scale, because it concentrates almost all the mass of the solar system and forces everything else to organize around it. The numbers are so uneven they are hard to believe. Out of every 100 parts of mass in the solar system, almost 100 are in the sun, and less than one is shared among all the planets, their moons, and the clouds of debris that accompany them. That means that, from the point of view of gravity and overall structure, the planets are little more than details, small corrections to the overwhelming presence of the central star, as if the solar system were really the sun, with decorations around it, rather than a collection of worlds sharing importance. Now imagine pulling back, like in those scale illustrations that zoom out step by step. First you see the inner orbits, then the gas giants, then the Kuiper belt with its icy remnants, until suddenly the entire solar system, with its dominant star and its planets, fits inside a small circle, barely a luminous point at the center of a black frame. All the region where the vicissitudes of the solar system, as a classic science writer might say, take place is reduced to a dot you have to point to with your finger to avoid losing it. What is interesting is that inside that dot lies the complete history of the sun, the motions of all the planets, the orbits of comets, the impacts, the eclipses, everything you have ever been told about our cosmic neighborhood. And yet, seen at that scale, it is nothing more than a speck of light, a detail within something much larger. If you keep pulling back mentally, there comes a point where the sun itself stops standing out. At a certain distance, a star like ours is barely visible without assistance, one among many others, and its size, if drawn to scale, would be comparable to that of an atom on paper. At that level, the entire solar system, with all its internal complexity, becomes a single point among countless other points populating a spiral arm of a galaxy. Imagine what that implies for the planets. If the sun itself shrinks to almost nothing in that perspective, the worlds that orbit it are even easier to lose. If the light that contains our entire history takes months to travel to that imagined point of observation, what you receive is not Earth, not Mars, not Saturn's rings, but an undifferentiated glimmer, one more spark among many. And yet, Even when everything is reduced to physical proportions, the sun remains the protagonist of the system. Its gravity defines the orbits, its solar wind sculpts the heliosphere, the bubble of plasma pushing against the interstellar medium. Its magnetic fields extend far beyond the planet's orbits. Its pulses of energy fill the space between them. The planets, by contrast, occupy only tiny fractions of that volume. Their orbits are thin threads inside an immense cavity. Even regions that seem dense to us, like the asteroid belt, are in fact extraordinarily empty. If you were standing within it, you would very likely see no asteroid at all with the naked eye, because each rock is millions of kilometers from the next. The familiar image of a swarm of rocks constantly colliding belongs to cinema, not to real physics. From this perspective, the solar system looks more like a vast, nearly deserted plain than a room full of objects. The sun would be a gigantic bonfire at the center, and the planets small stones circling at great distances, so far from one another that they almost never meet. The Earth is just one of those stones, located in a specific band where the sun's light warms enough to allow oceans and complex atmospheres. But in terms of available volume, it occupies very little. If the space inside Neptune's orbit were a city, the entire ensemble of the sun and all the planets would be something like a single house in that city, and the Earth a room in that house. It is difficult for the mind to accept, because emotionally we are used to feeling that our world fills everything, and yet this sense of apparent insignificance should not be read as a condemnation, but as a shift in focus. That the planets are insignificant in terms of volume does not mean they are insignificant in terms of meaning. They are insignificant to the system's geometry, not to the stories that unfold on them. The sun rules the desert, yes, but it is on those tiny points that things as improbable as liquid oceans, complex chemistry, stratified atmospheres, and, in at least one case, beings capable of looking outward and wondering about their place in all this appear. The true paradox of the solar system is this: from far away the planets disappear. From within, they are all we know. When you begin to internalize that you live in a desert ruled by a star that dominates almost the entire scale, the image of the solar system stops being an orderly map and becomes a far more dramatic landscape. You no longer see a row of aligned spheres. You see a gigantic gravitational well lit by a nuclear furnace, surrounded by extremely thin paths along which nearly invisible spheres travel, each accompanied by its own court of moons, rings, or stray rocks. And you are on the surface of one of those spheres, looking up, knowing that in the complete drawing, your planet is a point so small that any slip could erase it from the page. Understanding this does not reduce its importance to you, but it does remind you that, in terms of cosmic scale, even planets are marginal notes in a score written almost entirely by the sun. I want you to imagine, for a moment, that we have already reached the edge of the solar system, that we have left behind the planets, the moons, the asteroids, and even the most familiar comets, and that we keep moving outward as if riding a camera that never stops, widening the field of view until everything we once called our neighborhood becomes a simple point of light suspended in darkness. The sun's influence does not end at Neptune or the Kuiper belt. It extends outward, forming a gigantic bubble of solar wind and magnetic field, the heliosphere, a kind of cavity carved by the sun into the thin gas of the interstellar medium, with a diffuse boundary called the heliopause, which the Voyager probes crossed at more than 100 astronomical units of distance, becoming the first human emissaries to truly leave the region dominated by the planets and enter the space between the stars. If you think about it calmly, you realize that even this feat, which sounds enormous from our everyday experience, is only a very small step compared to the scale that comes next. Beyond Neptune's orbit and the Kuiper Belt, where the icy remnants of the solar system's formation reside, astronomers describe an even more remote and almost ghostly region. A vast sphere of comets enveloping the entire system like a distant shell, the Oort cloud, a reservoir extending tens of thousands of astronomical units, perhaps up to 100,000, so far away that the sun's gravity there already competes with that of neighboring stars. Very long period comets, those that take far longer than a human lifetime to complete an orbit, would come from that remote storehouse, occasionally falling inward from any direction, like sporadic messages from a frontier we will never see up close. What is fascinating is that although we speak of the Oort cloud as a concrete structure, no one has ever seen it directly. What we have are clues, comet trajectories, statistics, gravitational calculations that, taken together, trace the outline of something enveloping the solar system like an almost invisible sphere of ice. At that scale, the planets are details buried at the center of an enormous dome. And our idea of leaving the solar system becomes complicated because it is no longer enough to cross Pluto's orbit or leave the Kuiper Belt behind. One can speak of leaving the region of the planets, of abandoning the zone dominated by the solar wind, or of going farther still, beyond the Oort cloud, where the sun's influence dissolves into the galactic environment. Even when you cross the boundary of the solar wind and enter the interstellar medium, you are still relatively very close to the sun on a galactic scale, as if you had stepped out of your backyard but were still walking through the same city. The Earth is just one of those stones, located in a specific band where the sun's light warms enough to allow oceans and complex atmospheres. But in terms of available volume, it occupies very little. If the space inside Neptune's orbit were a city, the entire ensemble of the sun and all the planets would be something like a single house in that city, and the Earth a room in that house. It is difficult for the mind to accept, because emotionally we are used to feeling that our world fills everything. And yet this sense of apparent insignificance should not be read as a condemnation, but as a shift in focus. That the planets are insignificant in terms of volume does not mean they are insignificant in terms of meaning. They are insignificant to the system's geometry, not to the stories that unfold on them. The sun rules the desert, yes, but it is on those tiny points that things as improbable as liquid oceans, complex chemistry, stratified atmospheres, and, in at least one case, beings capable of looking outward and wondering about their place in all of this appear. The true paradox of the solar system is this: from far away, the planets disappear. From within, they are all we know. When you begin to internalize that you live in a desert ruled by a star that dominates almost the entire scale, the image of the solar system stops being an orderly map and becomes a far more dramatic landscape. You no longer see a row of aligned spheres. You see a gigantic gravitational well lit by a nuclear furnace, surrounded by extremely thin paths along which nearly invisible spheres travel, each accompanied by its own court of moons, rings, or stray rocks. And you are on the surface of one of those spheres, looking up, knowing that in the complete drawing, your planet is a point so small that any slip could erase it from the page. Understanding this does not reduce its importance to you, but it does remind you that in terms of cosmic scale, even planets are marginal notes in a score written almost entirely by the sun. I want you to imagine, for a moment, that we have already reached the edge of the solar system. that we have left behind the planets, the moons, the asteroids, and even the most familiar comets, and that we keep moving outward as if riding a camera that never stops, widening the field of view until everything we once called our neighborhood becomes a simple point of light suspended in darkness. The sun's influence does not end at Neptune or the Kuiper Belt. It extends outward, forming a gigantic bubble of solar wind and magnetic field, the heliosphere, a kind of cavity carved by the sun into the thin gas of the interstellar medium with a diffuse boundary called the heliopause, which the Voyager probes crossed at more than 100 astronomical units of distance, becoming the first human emissaries to truly leave the region dominated by the planets and enter the space between the stars. If you think about it calmly, you realize that even this feat, which sounds enormous from our everyday experience, is only a very small step compared to the scale that comes next. Beyond Neptune's orbit and the Kuiper Belt, where the icy remnants of the solar system's formation reside, astronomers describe an even more remote and almost ghostly region, a vast sphere of comets enveloping the entire system like a distant shell. The Oort cloud, a reservoir extending tens of thousands of astronomical units, perhaps up to 100,000, so far away that the sun's gravity there already competes with that of neighboring stars. Very long-period comets, those that take far longer than a human lifetime to complete an orbit, would come from that remote storehouse, occasionally falling inward from any direction, like sporadic messages from a frontier we will never see up close. What is fascinating is that, although we speak of the Oort cloud as a concrete structure, no one has ever seen it directly. What we have are clues, comet trajectories, statistics, gravitational calculations that, taken together, trace the outline of something enveloping the solar system like an almost invisible sphere of ice. At that scale, the planets are details buried at the center of an enormous dome. And our idea of leaving the solar system becomes complicated because it is no longer enough to cross Pluto's orbit or leave the Kuiper Belt behind. One can speak of leaving the region of the planets, of abandoning the zone dominated by the solar wind, or of going farther still, beyond the Oort cloud, where the sun's influence dissolves into the galactic environment. Even when you cross the boundary of the solar wind and enter the interstellar medium, you are still relatively very close to the sun on a galactic scale, as if you had stepped out of your backyard, but were still walking through the same city. Now I want you to carry that image one step further. Suppose you place yourself far above the plane of the solar system, far enough that everything inside Pluto's orbit fits into a tiny, bright smudge, and that in a page illustration, the entire solar system appears reduced to a minuscule speck against a black background, so that all the orbits and trajectories we struggle to imagine collapse into a single white spark. Up to this point, we are still talking about our immediate surroundings, but once you leave that frame, you are no longer in the solar system. You are in interstellar space, in the nothingness that separates one star from the next. And here is where that word you hear so often, but rarely truly feel, comes into play. Light years. They are not used as decoration. They are used because distances have grown so vast that talking about kilometers no longer makes sense. The nearest star to us, shown in those illustrations where the solar system is just a dot, appears only a few centimeters away on the drawing. But those centimeters represent 4 years of travel for light, 4 years moving at nearly 300,000 kilometers per second, without rest, without stopping for even an instant. If you convert that distance to any human speed, even to that of a theoretical spacecraft far faster than anything we have ever built, the travel time explodes into thousands or tens of thousands of years. In some examples, an object is imagined being launched from Earth at an enormous speed, several times the planet's escape velocity, something like hundreds of thousands of kilometers per hour, fast enough to leave not only Earth but the solar system itself, if nothing slows it down. And yet, when you calculate how long it would take to reach the nearest star, you discover it would need almost 20,000 years to cover those few light years. The number is so large that the mind protects itself by turning it into an abstraction. But if you think of it in terms of human generations, it means that no one who boarded that ship would ever see the destination, nor their children, nor their grandchildren, nor the descendants of their descendants for centuries. That is what travel really means when distances are measured in light years. It is not packing a suitcase, taking off, and spending a few hours or months in transit. It is committing to journeys that overflow the scale of a single life, of a country, even of a civilization, as we currently understand it. When we talk about interstellar space, we are not describing a highway with gas stations every so often. We are talking about an ocean where the islands are so far apart that light takes years to go from one to another, and anything slower moves at the pace of eternity. At the same time, there is an important nuance. The fact that the space between stars is almost empty, and the distances are gigantic, does not mean that this emptiness is completely barren. Even in regions where the density of matter is extremely low, there are magnetic fields, high-energy particles, clouds of gas so tenuous that you would need to pass through light years of them to collect the amount of air that fits inside a room. And even occasional visitors like those interstellar objects detected, crossing our system on trajectories that reveal their origin in other parts of the galaxy. That space seems empty, but in reality it is a physical medium, a very subtle fabric that connects one star to another. If you add all this together, you discover that leaving the solar system is not a single leap, but a sequence of layers. First, you leave the region of the planets and the asteroid belts. Then you pass through the zone filled with icy remnants of the Kuiper belt. Farther out, you enter the distant slope of the Oort cloud, where comet orbits nearly blur into the sun's gravitational boundary, until at last you cross the heliopause and truly enter the interstellar medium, that extremely thin gas that fills the space between stars. From that point on, continuing forward is no longer a change of neighborhood. It is a change of mental scale. Because in practice, the one thing we truly know how to do well at those distances is not to travel with our bodies, but to look with our minds and with telescopes. We can send probes that slowly move away from the solar system and cross the heliopause after decades of flight. But when we think about the nearest star or any other in our galaxy, what we really do is observe the light that reaches us from there. Light that has spent years crossing the void before entering your eyes or the camera of an observatory. Our real journey today is a journey in the signal, not in the spacecraft. That is why, when we use the word travel in the context of light years, we are stretching our language. Traveling to the Oort cloud would already be an achievement spanning multiple generations. Leaving it and reaching deep interstellar space would multiply that effort. Covering the distance to the nearest star would push us into numbers that test any sustained human project. And yet, thinking about it, imagining it, following the figures and turning them into images is already a form of travel, because even if your body remains here, your mind has shifted to a scale where the entire home fits into a single point, and the rest is darkness sprinkled with distant lights. I want you now to make an even greater effort and change scale once again, because you have already left the solar system, crossed the region of the planets, the cloud of distant comets, and the edge of the solar wind, and you now find yourself in a space where the sun, seen from afar, is no longer a dazzling disk, but just another star in the middle of an immense field of scattered lights. Imagine that your gaze slowly pulls back even farther, until you stop seeing individual stars and begin to see something else. A shape, a structure, a band of light that wraps around the sky like a diffuse, milky river. That is the galaxy we call the Milky Way. And within it, our sun is not the protagonist. It is simply one among hundreds of billions of stars. One more note in a gigantic symphony that began playing long before Earth appeared. If you could hold the complete image of the galaxy before you, you would not see it as a flat drawing or a decorative computer background. You would see it as a living structure, an enormous rotating disk of stars, gas, and dust, with spiral arms that curve outward like whirlpools of light frozen in time, a denser and brighter nucleus at the center, and an invisible halo of matter that emits no light but exerts gravity and holds everything together. Our solar system is in one of those arms, not near the center, not at the edges, but in an intermediate zone, a galactic suburb where things happen with a certain relative calm, far from the energetic bustle of the core and also from the darker regions of the outer boundary. At that scale, the sun stops being a reference point and becomes just another resident of a city of stars. Every point of light you see when you look at the Milky Way in the night sky is another star like ours, many of them with their own planetary systems, their own orbits, their own physical histories. Some are massive blue giants with short lives. Others are red dwarfs that can live for hundreds of billions of years. Some end in violent explosions. Others fade slowly. But all of them participate in the same overall motion, orbiting the center of the galaxy with a patience that shatters any human intuition of time. Our solar system takes about 200 million years to complete one full orbit around the galactic center, a galactic year that has passed only a few times since Earth formed. That means the surface you live on, the seas you know, the mountains you have seen in photographs, have traveled across the entire galaxy like a tiny rail car attached to a train that never stops, moving alongside billions of other cars, each with its own light, its own gravity, its small court of planets or debris. And meanwhile, on the scale of your life, everything seems still. When you think of the Milky Way as a simple, decorative backdrop, as that pale band sometimes visible on clear nights, you miss what is essential. It is not a motionless stage on which human history is projected. It is a machine in operation, a gigantic city where stars are constantly being born and dying, where clouds of gas collapse and give rise to new systems, where the remnants of ancient explosions enrich the material from which future generations of stars and planets will form. The calcium in your bones, the iron in your blood, the oxygen you breathe. All of it was forged inside stars that no longer exist, in stellar furnaces that exploded and scattered their remains through the galactic neighborhood until, much later, that material condensed again and ended up forming this small world where you are now. In that sense, you do not simply live in the galaxy. You belong to it. You are part of its cosmic recycling cycle. You are literally stardust reorganized into a conscious being, living on the surface of an insignificant planet orbiting an ordinary star, a system that itself travels through one of the arms of a spiral structure. And yet, your everyday experience does not tell you this. Your experience tells you that Earth is the center of your life, that your city is large, that your personal story occupies all available emotional space. It is normal to feel it that way. Your mind is built to process that scale, not to encompass an entire galaxy. But when you make the effort to lift your gaze and hold this galactic image, something changes in the way you place yourself on the map of the universe. Earth stops being the stage and becomes a private story within a colossal city of stars. Think of a great metropolis seen from the air, full of lights, roads, buildings, and neighborhoods. Every lit window is a home, a life, a distinct story that most of the city's inhabitants will never know. Your planet is one of those windows. A light turned on in a building lost in one of the galaxy's neighborhoods. A story unfolding in parallel with the billions of other stories we will never see. The great lesson of this scale is this: the Milky Way is not looking at you. It is not rotating around Earth, or the Sun, or the human species. You are in it as you might be in an anonymous building in an unknown city. And yet inside that tiny window called Earth, everything acquires an intensity that no galaxy can experience globally. The life that arises here, the thought that looks outward and asks about its origin, the ability to write books, build theories, imagine journeys, all of that happens at a point that, if reduced to galactic scale, would be smaller than the stroke of a pencil. And yet, for you, it is everything. What is beautiful about seeing the Milky Way as a living structure, rather than decoration, is that it allows you to hold two truths at once, without them canceling each other out. On the one hand, it shows you that you are tiny in size and influence, that your world is a microscopic island in an ocean of stars, that nothing that happens here will alter the course of the galaxy as a whole, that the spiral arms will continue to rotate in total indifference to your daily problems. But at the same time, it reminds you that precisely because of that smallness, that improbability, that very specific corner of physical conditions, the story you are living is unique, unrepeatable, one of the many private stories that give texture to the great structure we call a galaxy. When you think this way, the Milky Way stops being a pretty postcard and becomes the city where you live, even if you never walk it with your feet. You begin to see that every star shining in the sky is another possible window, another system, another context where perhaps, somewhere and sometime, something capable of asking questions similar to yours may exist or may have existed. Earth, then, is your starting point, not your crown. It is the balcony from which you look out over a city of lights that extends beyond anything any human map can contain. And in that image, you are still you, with your problems, your fears, and your joys. But you are no longer at the center of the universe. You are at the center of your story, which is very different. The galaxy will keep rotating. The sun will keep completing its orbits around the core. Stars will continue to be born and die for billions of years after the human species has ceased to exist. But meanwhile, here and now, in this small corner of a spiral arm, you have the opportunity to be aware of all this, to know that your life takes place in an almost invisible corner of a gigantic structure, and still feel that it is worth living with your eyes wide open. I want you now to take an even bigger leap and try to hold it without shrinking your mind, because up to this point, we have spoken of the Milky Way as if it were almost the final scene, a colossal city of stars where our sun is just one more. But in reality, the galaxy is only an intermediate step on the scale of the universe. Imagine pulling back so far that the spiral shape of the Milky Way no longer fills your entire field of view, but only a part of it, a swirl of light among many other swirls, each with hundreds of billions of stars, each with its own planetary systems, gas clouds, central black holes, and long histories of formation and destruction. What was once the totality of your world is now just one unit in a vast catalog of galaxies, some similar, others irregular, others elliptical and massive, that group and interact with one another through gravity, like cities in a network of cosmic continents. If you continue pulling back mentally, galaxies stop appearing as isolated objects and begin to form larger structures called clusters, regions of space where gravity has gathered dozens or hundreds of galaxies orbiting around a common center. They are not compact spheres, they are swarms, dispersed collections, where each galaxy moves along trajectories lasting billions of years. Between them, there is no air or anything resembling a medium you might imagine. There is an extremely hot, diffuse gas, shared gravitational fields, and a vast amount of invisible matter that holds everything together. From that distance, the Milky Way, with its delicate spiral structure and its billions of stars, no longer shines as something special. It is simply one of many galaxies that belong to a local cluster, just another member of a group in which other galaxies carry as much weight as it does, or even more. And yet the story does not end there, because those clusters themselves organize into even larger structures called superclusters, enormous filaments and walls of galaxies stretching across hundreds of millions of light years, forming a kind of cosmic web where dense regions appear as nodes and empty zones open up like gigantic caverns with almost no galaxies. Think of a sponge seen up close, or a spider web lit from the side with bright threads and dark gaps between them. At that scale, the universe looks more like a network than a loose collection of objects, because galaxies are not distributed at random. They follow patterns born from tiny fluctuations in the early universe, amplified by gravity. What is astonishing is that when you draw these large-scale maps, there is no human way to place Earth on them. It does not appear, it cannot be seen, and not even the entire galaxy stands out in any significant way against the rest. Here, an idea we have been carrying since we left the initial room is fulfilled. Every time you climb a level of scale, what once seemed central shrinks into a detail. And at this level of clusters and superclusters, Earth not only disappears visually, it disappears from the narrative. You cannot mark it on a graph spanning hundreds of millions of light years. You cannot draw it alongside the trajectories of galaxies. You cannot even say it's around here without pointing to a volume so large that your planet is lost within it, like an atom in an ocean. If a few sections ago we were still talking about Earth as a point, now not even that, because the point you could represent would, at minimum, be the size of a galaxy. And even that would be a simplification of realities, far too complex to fit into a single stroke. At this height, the universe begins to reveal something uncomfortable. It is not waiting for you. The great cosmic structures do not change their dance because there is life on a particular planet or because a species exists that can describe them. Clusters will continue to move. Superclusters will continue to expand along with space itself. Galaxies will continue to collide and merge. Stars will continue to ignite and fade in total indifference. For billions of years, there was no one here to look at any of this, and it is very likely that for many billions more, the universe will continue its process without conscious witnesses in most of its corners. That is one of the strangest truths you must accept when you play at this scale. The universe does not need to be observed in order to exist. However, the fact that the universe does not need witnesses does not mean that witnesses do not matter. What changes is the direction of importance. From the perspective of large-scale structures, your existence alters nothing, but from your own perspective, knowing that you are part of this gigantic web changes the way you tell yourself your own story. When you think about galaxies, clusters, and superclusters, Earth becomes a private confidence, an intimate narrative unfolding in a tiny corner of the map. A story the universe does not hear, but that you can understand. And that simple fact, being able to look outward and reconstruct this path of scales, is already something extraordinary. If you look closely, this entire journey through size has been undoing an initial illusion, the idea that the universe must be organized around what you see. First, it was the room, then the city, the planet, the solar system, the galaxy. Each step outward has shifted the center of the scene. And in this stage, when you are already dealing with clusters and superclusters, the center disappears completely. The observable universe presents itself as an expanding network with no privileged point, where any observer in any galaxy would see something similar if they performed the same exercise. That is what it really means, that the universe does not need witnesses. It is not a tragedy. It is a statement of fact. The stage exists on its own, whether or not there is someone in a corner capable of describing it. And yet, you are here, in that corner, mentally traversing these scales with a sometimes unsettling ease, because even though your body will never leave Earth, your mind can rise from the surface of a planet to the network of superclusters in a matter of seconds, simply by adjusting imagination. Earth no longer appears on the map, but it remains the place from which you look, the starting point of this conceptual excursion. The universe can do without you, but you cannot do without the universe to understand who you are, because each layer of scale reminds you that your personal story, however intimate it may be, is written within an immense architecture that sustains itself, with or without an audience. And it is precisely the mixture of physical insignificance and capacity for understanding that makes this journey meaningful. If you have made it this far with me, you have already seen how Earth shrinks as we widen the scale, how the solar system becomes a desert, how the galaxy stops being the central stage and becomes just another city within a gigantic network. But we are still playing on ground that, in a sense, belongs to us, because it is still our universe in the everyday sense, the one we can imagine with maps, diagrams, or simulations. Now it is time to take a different step, not so much outward as toward the very edge of what we can know, towards something cosmology calls the observable universe, an expression that sounds simple but hides a profound idea. We do not see everything that exists. We see only what has had time to send us a signal since the cosmos began. Think for a moment of light as a messenger. Every photon that reaches your eye or a telescope has traveled for a specific amount of time through space, covering distances with a maximum limit, the speed of light. If the universe has a certain age and light cannot travel faster than that, then we can receive information only from a limited region, a kind of bubble centered on us, within which everything has, at least in principle, been able to send us information. Everything outside it, no matter how real it may be, remains completely silent to us. That limit is called the particle horizon, and it is like standing in the middle of an immense plain, surrounded by fog in every direction. You can see only up to a certain distance, not because there is nothing beyond it, but because the light from there has not yet had time to arrive. The most disconcerting thing is that this horizon is not a physical wall. There is no glass edge or luminous barrier. It is simply the point to which light has been able to travel from the origin of the universe until now. So when you look very far out into space, you are also looking very far back in time. You do not see what those regions are like now. You see what they were like when the light left them. And the farther you look, the younger the universe you are seeing. There comes a moment when you go back so far that galaxies and stars no longer appear. All you see is a very faint, almost uniform light filling the entire sky. A radiation that originated when the universe was so hot and dense that matter and light were nearly glued together, like a glowing fog. That glow, cooled and stretched by cosmic expansion, is the cosmic microwave background, the fossil imprint of a baby universe that we will never be able to see in greater, direct detail, because before that moment, the cosmos was opaque. Light could not travel freely, as if you were looking backward into an ever-thickening fog, until there is no way to see anything beyond. From our point of view, the observable universe is like a sphere centered on you, on me, on any observer, with a radius of tens of billions of light years. Inside that sphere is everything that can ever influence us through light or gravitational signals, everything that can form part of our cosmological history. Outside it continues an exterior that we cannot directly map, regions expanding so fast that their signals will never arrive, galaxies receding so quickly that the light they emit today will never be intercepted by us, even if we waited for eternity. This exterior is not an arbitrary assumption. It is the natural consequence of an expanding universe that, according to everything we know, has no edge, does not end in a wall, but extends far beyond what our observational bubble allows us to see. Here, a nuance appears that completely changes the meaning of phrases like everything that exists. Very often, when someone says the universe, they are thinking of the observable universe, of that sphere from which we can collect signals, as if it were the whole, the absolute totality. However, all evidence suggests that it is only a portion, a finite region within a broader cosmos, perhaps vastly larger, perhaps even infinite, where there are more galaxies, more structures, more physical histories that will never be connected to ours, neither now nor in any possible future. Our most ambitious map is, at heart, the map of an island, a fragment of reality cut out by a physical limit we cannot cross, either with technology or with data-based imagination, because quite simply, no signal crosses it. To make all of this even stranger, the horizon is not fixed. It changes with time. It grows, because light keeps traveling and the universe keeps expanding. That means that in the future, we will be able to see regions that today lie right at the edge of our visibility. In the same way that, if you stand still in a field at dawn, sunlight will gradually reveal things that were initially in shadow. But at the same time, because of the accelerated expansion of space, there are galaxies moving away so fast that their light is stretched to wavelengths impossible to detect, lost forever beyond our cosmological event horizon, a more subtle boundary that marks which regions of the universe will leave any trace in our future, and which will disconnect forever from our history. So while some regions enter our observable sphere, others depart never to return, and the sky of the distant future will be poorer in visible galaxies than the sky we can observe today. From a human point of view, that combination of horizons produces a curious sensation, as if we lived in a window that is opening and closing at the same time. In one sense, we belong to a privileged era in which we can still see a great number of distant galaxies before they disappear beyond our event horizon. In another, we are completely local, unable to access what lies beyond the ring of light that surrounds us. What we obtain is a relative everything. Everything we can observe, everything that can affect us, everything that enters our light cone, but not necessarily everything that exists in an absolute sense. It may help to think about this with a closer analogy. Imagine that you live on an island surrounded by an infinite ocean and that you can see only as far as the marine horizon, that circular line where the water seems to touch the sky. From your point of view, everything you see is the world. You have ships and coasts, winds, waves, clouds, and you can map every detail of that circumference. But the fact that your sight ends at that circle does not mean that beyond it, there are no continents, no other islands, no even larger oceans. There is simply no way to see them from where you stand. The observable horizon of the universe is that edge of the sea, a visual limit that does not mark the end of the ocean, only the end of your ability to see it. When cosmology speaks of the observable universe, it is not saying this is the entire universe. It is saying this is the region with which we can be in contact. That distinction may sound semantic, but it changes everything. The temptation to believe that the observable sphere coincides with reality is strong, because our minds have always worked that way. For centuries, it was thought that the celestial vault was the limit of the world. Later, that the Milky Way was all of reality. Then, that the set of visible galaxies constituted the entire universe. Every time we widen our view, that supposed everything dissolves and another level appears. With the concept of the horizon, the same thing happens, except that now the limit is no longer naive, but physical, imposed by the speed of light and the age of the cosmos. In addition, some theories propose that what we call the universe could be just one bubble within an even larger structure, perhaps a multiverse composed of many regions with different properties, different densities, even different physical constants. You do not need to go that far to grasp the central idea. It is enough to accept that beyond our horizon, there may be more of the same, more galaxies, more matter, more emptiness, or perhaps something different, but that, by definition, all of it lies outside the observable universe and can never be included in our catalogs. What we can do is infer from what we see here what that exterior might be like, in the same way you could infer that there is more sea beyond the horizon because waves keep arriving at your shore. When someone says, everything that exists, while thinking of the universe we know, they are really talking about everything that fits inside this observational bubble, this finite volume that our telescopes and equations can explore. Yet, everything there is may include regions forever separated from us, sectors of the cosmos to which we will never send a message or a spacecraft, and that will never send us any signal in return. This separation does not depend on will or technology, but on the very structure of space and time. There are parts of the universe that even the universe from here cannot see. This does not mean that our map lacks value. On the contrary, the observable universe is, in fact, everything we need to build a coherent cosmology from our position. It contains enough galaxies, clusters, voids, and fossil radiation to reconstruct an enormous history, from the earliest moments to present-day structures. And that history is valid even if we know it describes only one region. No inhabitant of another, distant galaxy will have a map identical to ours. Their observable universe will be another one, centered on their position, different in detail, even if it shares the same deep laws. What is truly astonishing is that, from any one of those points, the cosmos appears homogeneous on large scales, with no privileged center, indicating that this bubble is not located in any special place. It is just one bubble among many possible ones. Seen from this perspective, Earth, which just a few sections ago still defended its emotional importance, is not only small compared with galaxies or clusters, it is a tiny anecdote inside a finite region that itself may be a small part of something much larger. And yet, within that anecdote, you have built your entire experience of reality. To live in the observable universe is to inhabit a fragment that, for you, functions as a totality. To work with a map you will never be able to complete, but that nonetheless allows you to orient yourself, understand processes, predict phenomena, and above all, become aware that what exists for you does not exhaust what exists in itself. That difference, which seems very abstract, has a curious effect on how one places oneself in the world. On the one hand, it lowers any pretension that reality begins and ends where your instruments stop. It reminds you that your vision, however advanced, has a horizon. On the other hand, it turns that horizon into something valuable, because within it happens everything you can know, everything you can measure, everything you can tell. You do not have access to the totality of the universe, but you do have the ability to understand that there is more beyond you, and that understanding may ultimately be what truly makes this small corner from which you look so great. Up to now, we have been expanding the scale of the universe step by step, and each jump has reduced a little more the place Earth occupies on the map. But there was something common to all those levels. We were always talking about things that, in one way or another, emit or reflect light: stars, galaxies, clusters, glowing gas, all of them composing the visible universe that telescopes record as spectacular images. The strange turn comes when cosmology begins to realize that this luminous universe is not the main actor in terms of content, that everything you see in photographs and animations, from colorful nebulae to galactic spirals, belongs to a minority of what actually exists, as if the shop window were only a small strip of a gigantic store filled with shelves in the back room that are never lit. What you call matter, the stuff that makes up your body, the planets, the air, and the stars, turns out to be only a fraction of a universe in which most of the content is made of invisible ingredients that neither shine nor reflect nor leave a direct trace in light. Imagine a spiral galaxy like those that fill popular science books, arms full of stars, pink clouds where new suns are born, a brighter center where old generations of stars accumulate, and, very likely, a massive black hole. At first glance, it seems that everything that matters is in what you can see, that the world is held together by the combined gravity of those stars and some gas. Now think about what happens when you carefully measure the speed of those stars orbiting the center. At the edges of the galaxy, they move far too fast for the amount of visible mass present, as if they were tied to an iron ring that does not appear in any photograph. If only luminous matter existed, many stars would have been flung out into intergalactic space long ago. Yet everything remains bound, as if there were some kind of invisible halo providing the missing gravity. From this arises the idea of dark matter, not as a definitive answer, but as an honest name for admitting that something is missing. It is not enough to fix a single galaxy. The same problem repeats in clusters, in the way gravity bends the light of distant objects, in the distribution of large-scale structures. And every time you compare how much matter should be there according to gravity with how much matter you actually see shining, the result is similar. The visible part is the minority. In current models, dark matter contributes several times more mass than all atoms combined. It does not form stars or planets, does not participate in chemistry or in life as we understand it, but it acts as a gravitational skeleton that wraps galaxies in large halos and fills clusters, determining where the structures we can see are formed. Where you perceive an elegant disk of stars, physics tells you that there is a dark, silent cloud holding everything together from the shadows. What is unsettling is that this dark matter seems to interact very little with normal matter beyond gravity. It does not form atoms with electrons, does not emit thermal radiation as it cools, does not leave spectral lines by which light is analyzed. That is why it does not appear when you observe the sky with optical, X-ray, or infrared telescopes. Its presence is inferred the way you would infer a hidden crowd by looking at a tarp sagging under weight. You do not see the people, but you see the tarp deform, and from that you infer how many are underneath. In that sense, almost all the work dark matter does in the universe is anonymous. It cannot be photographed. It appears only in equations and graphs, where the total mass demanded by gravity far exceeds the normal matter that has been counted star by star. And when it seems that the universe is already strange enough, with that invisible mass dominating the balance, observations of distant supernovae arrive and add yet another layer of bewilderment. For a long time, intuition suggested that the expansion of the universe, initiated in the Big Bang, should gradually slow down because the gravity of all matter, visible and dark, acts as a brake on the motion of galaxies, just as Earth's gravity slows a stone thrown upward. However, when astronomers carefully measured how the recession speed of very distant galaxies changes, they reached precisely the opposite conclusion. The expansion is accelerating. Galaxies are separating faster and faster, as if space itself had decided to step on the accelerator. Explaining this behavior cannot be done simply by adding more matter. It requires introducing a new component, one that does not clump into objects or concentrate in particular places, a form of energy associated with empty space itself that pushes everything outward. This ingredient is called dark energy, and although its name sounds similar to dark matter, its role is very different. It does not create halos or hold galaxies together. It acts like a negative pressure inherent to space, a tendency of the fabric of the universe to expand at an accelerating rate. When you add up the numbers, the result is almost insulting to human intuition. Dark energy contributes the largest fraction of the universe's total content. Dark matter makes up a large part of what remains. And normal matter, the matter of atoms, stars, and planets, occupies only a small percentage of the whole. It is as if you discovered that all the visible scenery of a theater, the lights, the actors, the props, represents only a few scattered pieces inside a colossal building whose volume is filled with invisible machinery and rooms no one ever enters. At this point, the mental map of the universe you carry in your head flips upside down. Before, you felt small because the cosmos was vast. Now you discover that, in addition to being small, you are made of a statistically marginal type of matter, belonging to a rare class of cosmic content that barely weighs anything in the overall balance. Earth, the solar system, the galaxy, even the visible universe are built upon a foundation of matter and energy that does not participate in your direct experience. You do not see it, touch it, or breathe it, yet it determines how structures grow, what shape the galactic web takes, and what the distant future of cosmic expansion will be like. The visible is the exception, not the rule. You inhabit the decorative part of a reality dominated by the dark. Yet this numerical irrelevance carries a curious twist. Precisely that minority of normal matter is what generates complexity. Stars that forge heavy elements, clouds that collapse into planetary systems, surfaces where liquid water can exist, atmospheres, chemical cycles, and, at least here, life that organizes itself into cells, organisms, brains, and thoughts. Dark matter holds galaxies together, but it does not write equations. Dark energy governs expansion, but it does not sit down to contemplate the night sky. What is rare is exactly what allows the existence of interlocutors capable of wondering about all this, and you are part of that rarity. Seen this way, Earth occupies a double edge. It is insignificant in size, irrelevant in mass, made of a minority type of matter. And at the same time, it is one of the few places we know where that type of matter has reached such a degree of organization that it can reconstruct the history of the universe and conclude that almost none of what composes it is visible. This may be the most human paradox of the entire story. You cannot compete with the physical magnitudes of the cosmos, but you can understand your own smallness with considerable precision. You live at a lost point, built of matter that barely counts in cosmic statistics, surrounded by dark components you will never see, and yet you have the capacity to draw this mental map and give it meaning. What remains after accepting this image is not a feeling of defeat, but a change in how importance is measured. Earth does not weigh on the universe's scales. The human species does not alter the evolution of dark energy. The galaxy will continue on its path with or without us. But in this specific corner, in this small band of visible matter, there is something the rest of the cosmos, as we understand it, does not do. Become aware of itself, organize data, build theories, tell itself a story about where it is and what it is made of. You are part of a cosmically irrelevant minority in terms of mass, but you are also an expression of what that minority can achieve when conditions align. And perhaps, in the end, the value of this journey lies not in climbing ranks in the hierarchy of the universe, but in calmly accepting that your world is small, strange, and statistically unimportant, and still deciding that it is worth caring for it and continuing to look outward. If now, instead of continuing to move outward in space, we begin to move outward in time, the vertigo is different but just as deep, because you are no longer comparing sizes or distances, but ages, durations, temporal scales that do not fit within human experience. When you read that the universe is about 13.8 billion years old, the number sounds large but abstract, like a figure the mind slides over without grasping. And the same happens when you are told that Earth is about 4.5 billion years old, or that life has been transforming this planet for billions of years. Everything blends into a vague, a very long time in which it is hard to place anything. For these ages to begin to mean something, you need to change your frame of reference and construct a kind of cosmic calendar where you can see at a glance how much space each chapter occupies. Imagine that we take the entire history of the universe, from the first instance after the Big Bang to now, and compress it into a single year. Not an ordinary year of your life, but a symbolic year in which the universe is born at midnight on January 1st, and the present occurs precisely at the chimes of December 31st. In that compressed calendar, the initial expansion, the formation of the first particles, the appearance of light nuclei, everything decided in fractions of a second after the origin, would occupy less than a sigh in the early hours of the first day. The first stars do not appear until many months into this imaginary year, when primordial gas begins to clump under gravity and lights the first beacons in the darkness. Galaxies, those whirlpools we have been looking at in previous sections, form and reorganize over much of the year, merging, growing, interacting with one another in a slow dance that lasts hundreds of millions of real years. but which on our compressed calendar might span from the first days of spring, well into autumn. In this context, the Milky Way is just one of many structures gradually consolidating, like a city built through neighborhoods, demolitions, and expansions, while the cosmic clock keeps advancing. Earth, on this same calendar, does not appear until late summer. If the universe is born on January 1st, our planet forms around September 1st, more than 2/3 of the year after the beginning. That means that for most of a cosmic history, there is no Earth, no solar system, no sun as you know it. What you consider the world is a fairly late chapter in the universe's biography. The solar system emerges only after previous generations of stars have lived and died, enriching the gas with heavy elements that make rocky planets, oceans, and eventually complex life possible. Only after those stellar cycles can a place like this exist. If you continue with the year metaphor, life on Earth does not take long to appear after the planet forms. By late September, the first very simple life forms arise in the primitive oceans, microscopic organisms utterly unlike you but inaugurating an unbroken chain of descent that reaches the present. For months of that imaginary year, there are no plants, no animals, no forests, no insects, nothing that could be called a familiar landscape, only worlds of microbes, changing atmospheres, oceans slowly filling with oxygen thanks to tiny creatures that do not even know they are modifying the planet. Complex life, in the form of multicellular animals, does not appear until December. The entire age of dinosaurs, of vast forests and seas full of strange creatures, occupies only a few weeks of that final month. It feels enormous when you look at the geological scale, but here you are already in the final stretch of the year. And when you reach mammals, the first forms resembling us, the species that walk on two legs, you are getting very close to the final hours of December 31st. Now place anatomically modern humans on this calendar. The first humans you would recognize as like you appear in the last hours of the last day of the year. Writing, agriculture, cities, empires, recorded history, everything that fits into school textbooks happens in the final seconds before midnight. It is as if the entire history of your civilization were a microscopic spark, almost glued to the edge of the page. If the cosmic clock strikes 12 at the present moment, the millennia of written human history fit into a blink of the clock's hands. You can change metaphors if you like. Imagine stretching the entire history of the universe along a 100-meter line. The birth of the universe is at one end of the tape, and the present at the other. In the first meters, the fundamental laws are set. The first particles form, and radiation dominates the landscape. Farther along, halfway down the tape, large-scale structures consolidate. Galaxies become distinct, and entire generations of stars ignite and fade. Earth appears after you have walked more than 70 meters. Complex life appears near 90-something. Human history lies in the last millimeters before the end. Yet your life occupies a tiny fraction within those millimeters. So small, you would need a magnifying glass to mark it. The consequence of seeing it this way is clear. In terms of cosmic time, your story, the story of your family, your species, fits into a blink. This is not a poetic metaphor. It is a fairly accurate description. If you compare Earth's 4.5 billion years with the few thousand years of documented history, the proportion is so extreme that the slice of time containing philosophy, science, right, technology, and narratives like this one is almost imperceptible. Even more extreme is the comparison between the age of the universe and the time anything resembling a human being has existed. Most of the universe has functioned without conscious witnesses, and it will continue to do so long after there is no one left to describe it. This contrast can feel almost aggressive to human pride, because you have spent your life measuring time on human scales. When you say ancient, you think of a few centuries or, at most, a few thousand years. Geological epochs already strain the imagination, because millions of years are hard to visualize. Jumping to billions is like leaving the language altogether. You simply have no experience that serves as a reference. The mind is not built to intuitively handle such durations. You need tricks, compressed calendars, tapes, metaphors, any resource that brings those numbers a little closer to something you can imagine. Yet at the same time that it diminishes you in temporal size, this image also offers a new way of understanding the fragility and value of that blink. Precisely because your chapter is so short on the cosmic calendar, anything that happens within it is extremely fragile. Entire civilizations can flourish and disappear, leaving almost no trace on a galactic scale. Whole species can arise and go extinct without the universe as a whole changing its rhythm. Forests, oceans, habitable climates, even the conditions that allow beings capable of asking about time, are sensitive to changes that, compared with the background of history, are tiny and rapid. Think about how much the world has changed in just the last 200 years. Industrial, technological, and digital revolutions, population growth, landscape transformations, emissions that alter the climate. Now compare that with the relative stability Earth maintained for millions of years before the human species appeared. In that context, your blink is not only short, it is also intense, concentrated, compressed, as if in the last seconds of the cosmic year, the local plot of this planet had sped up. And in the middle of that acceleration are you, trying to make sense of the fact of existing right now and not at some other moment on the calendar. The comparison between the age of the universe and the age of Earth adds another layer of perspective. Earth has existed for approximately 1/3 of cosmic history. It is not an absolute newcomer, but neither is it ancient. It is a middle-aged world in astronomical terms. It formed when the universe had already produced several generations of stars and heavy elements. But there was, and still is, plenty of time ahead for systems to continue forming. That means you not only come after many things, but also before many others that have yet to occur. You are an inhabitant of a universe that is neither in its infancy or in its extreme old age, something like a very extended midday on the cosmic scale. Looking backward, you see an overwhelmingly vast past in which your planet did not exist or was not habitable for creatures like you. Looking forward, models suggest an equally immense future in which the universe will continue expanding. Galaxies will drift apart, stars will fade, and the sky of the future will gradually empty. Within that framework, the period in which there is a solid Earth with oceans and an atmosphere, and on top of that, intelligent life capable of developing technology, is a narrow interval, probably bounded by many physical and chemical factors. Human history not only fits into a blink when you look backward, it will also fit into a blink when someone, or something, if anyone remains, looks back at this time from far away. You might think all of this reduces your importance to almost nothing, that being a psi within a cosmic year invalidates any claim to significance. But you can also reverse the reading. The fact that your story fits into a blink does not make it less real. On the contrary, it makes it more precious, because it is an extremely delicate coincidence of conditions. A universe with certain laws, a galaxy that produces enough heavy elements, a star stable for billions of years, a planet in the right zone, an evolutionary chain that leads to beings capable of telling this story, all concentrated into a time interval so small that if you blinked, on the scale of the cosmic year, you would miss it entirely. Ultimately, cosmic time is not there to humiliate you. It is there to situate you. It reminds you that you are not the beginning or the end of anything, that your life takes place in the middle of a much longer story that began long before you and will continue long after. The age of the universe compared with the age of Earth, and both compared with the age of your species, and with your own biography, build a chain of proportions in which each link is shorter than the last, until you reach your days, your hours, your specific moments. The fact that all that you are fits into a cosmic blink does not make it less profound. It simply makes it more aware of its condition as an instant. And perhaps understanding it this way is, in the end, a way of taking better care of that instant while it lasts. If you have followed this entire journey of scales, suddenly the universe is no longer just a map of places, but also a kind of factory of slow time. And here a question appears that we often take for granted but deserves careful attention. Where did everything you are made of really come from? I do not mean only Earth as a planet, but the calcium in your bones, the iron in your blood, the oxygen you breathe, the carbon in your skin. Because the universe, in its infancy, was not made of these things. There were no mountains, no oceans, no rocks, no DNA. There was not even oxygen or carbon in appreciable quantities. There was mostly hydrogen and helium, a bit of lithium and little else. An extremely simple, elemental broth from which, at first glance, nothing as complex as you could emerge. Imagine those first moments after the Big Bang as an enormous furnace that operates for a few minutes. A furnace where temperature and density are so extreme that matter can only organize itself into very basic forms. In that furnace, the lightest nuclei form. Proportions are set that we later recognize as the universes. But the furnace cools too quickly to manufacture iron, gold, calcium, or silicon. It is as if the universe had a first chance to make elements and used it only to build simple materials, small, uniform bricks, leaving the rest of the work for later. The entire periodic table you learn in school was not there at the beginning. Most of it had to be built afterward, in other places and at other times. And this is where stars enter the scene, not just as points of light, but as true workshops of transformation. Each star is a balance between two forces: gravity, which tries to compress it, and the pressure generated by the nuclear reactions in its interior, which tend to push outward. As long as that balance is maintained, the star lives a more or less stable life, slowly consuming the hydrogen in its core and converting it into helium through nuclear fusion. In that process, energy is released and escapes in the form of light and heat, the same light you see in the night sky or feel on your skin when you step out into the sun. But in the long run, what matters is not only the light, it is also the fact that those light nuclei are gradually fusing into heavier ones. Over time, in more massive stars, helium becomes carbon, carbon becomes oxygen, then neon, silicon, and so on, until iron is reached. Each stage involves increasingly extreme conditions of temperature and density, as if the star were igniting successive layers of an internal furnace that grows ever hotter. In the hearts of these stars, the periodic table of elements that a rocky planet needs in order to exist is slowly written. But there is a limit. Iron is a kind of energetic boundary. Fusing it does not produce energy, it absorbs it. And when the core of a massive star fills with iron, the balance breaks. Gravity suddenly wins, the core collapses, and the outer layers rebound against that brutal fall, triggering an explosion we call a supernova. In that explosion, something happens that the universe cannot do peacefully. Elements even heavier than iron are created, under violent shocks and intense flows of neutrons. Gold, platinum, uranium, many of the elements we associate with exotic or valuable things, are forged in those moments of cosmic violence, when a star stops living as such and becomes something else, a neutron star, a black hole, or simply a dispersed remnant. In addition to supernovae, collisions between neutron stars and other extreme processes also contribute to this repertoire of heavy elements. The essential point is that this kind of advanced chemistry does not happen in calm conditions, but in cataclysms. Now imagine that you are looking at the entire galaxy as a very long-term cycle. Generations of stars are born from clouds of hydrogen and helium, live, shine, and some die quietly, while others die in colossal explosions. Each star that dies returns part of its material to the interstellar medium, enriching the gas with new elements. It is as if the galaxy breathes through its stars. It inhales primordial gas and exhales enriched gas. After many rounds of this cycle, the content of the galaxy is no longer the same. Where there was once only hydrogen and helium, there are now carbon, oxygen, silicon, iron, and a whole collection of elements that were not there at the beginning. At some point, in some region of one of those clouds, the enriched material begins to collapse again, pulled by gravity. From that collapse, a new star is born, our Sun, surrounded by a disk of gas and dust in which fragments, grains, rocks, and later planetary embryos gradually accumulate. Those grains are not pure matter. They are mixtures of elements forged in earlier stars, fragments of previous stellar histories compressed into tiny particles. When those grains stick together, first as small rocks and later as larger bodies, they are doing more than just building a physical planet. They are recycling stellar debris. The Earth, in this context, is not an original object. It is a recycled product of the galaxy. The rocks you walk on contain atoms that were once inside stars that exploded billions of years ago. The iron in Earth's core, which helps generate the magnetic field that protects life from cosmic radiation, was forged in the heart of some massive star. The calcium in your bones, the phosphorus in your DNA, the oxygen in the water you drink, the nitrogen in your blood, all of these atoms were, at some point, part of material expelled into space by stars that no longer exist. What you today call a planet is, in reality, a pile of stellar ashes gathered, heated, differentiated, and reorganized during the formation of the solar system. When you think about it, the phrase "we depend on dead stars" stops sounding poetic and becomes a literal description. If the universe had remained hydrogen and helium, there would be no rocky worlds, no liquid water, no complex chemistry, no consciousness. Earth is only possible after several generations of stars have lived and died, cooked their material, scattered it through space, and faded away. The existence of this planet implies a physical memory of those earlier stellar lives, stored in the chemical composition of the soil, the air, the oceans, and your own body. This also changes how you see the relationship between the Sun and the Earth. Our Sun is a relatively young star compared to the first generations, and it is itself a product of that recycling. It is made of gas that contains traces of earlier nuclear processes. It orbits the galactic center along with other stars of its generation, carrying with it a small retinue of planets, asteroids, and comets that together form a kind of advanced chemistry laboratory built on the remains of stellar furnaces that went out long ago. The entire solar system is a byproduct of a galaxy that had already been creating and destroying stars for billions of years before our world appeared. If you look at the night sky with this in mind, stars stop being just distant points of light and become earlier versions, and possible future versions, of what made your existence possible. Some are right now fusing hydrogen into helium, like a more or less young sun. Others, more massive, are silently preparing their spectacular end, stacking layers of elements inside. Others have already died, and all that reaches your eyes is the light of a past that has gone out. What sustains you here is not only the light of the sun, but an entire lineage of stars you can no longer see, whose remains became the material of your planet. Thinking of Earth as recycled stellar residue does not diminish it, it situates it. It humanizes it, in a sense, within the history of the cosmos. This planet did not appear by magic in a static universe, but as the final result of an extremely long chain of physical processes, in which each generation of stars added a chapter to the periodic table. When you pick up a stone, when you touch the bark of a tree, when you feel air in your lungs, you are in direct contact with that memory of dead stars, with layers of cosmic past reinterpreted as mountains, rivers, living organisms, and nervous systems. At the same time, that condition of recycled residue makes Earth part of something larger than itself. It is not an isolated object that fell from the sky without a history. It is an episode in the history of the galaxy, a particular form taken by the remnants of previous explosions and collapses. What today is solid ground, ocean, atmosphere. Biosphere was once dilute gas drifting through the space between stars. It was supernova ash traveling for millions of years until it mixed with hydrogen clouds. It was part of structures we will never know. In a sense, the entire planet is a physical archive of those processes, even though we have only learned to read a tiny fraction of what it tells. And you stand halfway between reader and part of the text. You are a temporary combination of atoms that have passed through that chain of recycling, organized for a few decades into the form of a human body, capable of thinking, remembering, imagining, and placing itself within this story. The elements that make you up were once elsewhere and will be elsewhere again when you are gone. What is yours now is, in reality, a brief loan of material that has traveled for eons through stars and clouds of gas. At bottom, all of this can be summed up in a simple but powerful image. The universe began almost empty of chemical possibilities and, by lighting and extinguishing stars, gradually enriched itself until it produced worlds like Earth. This planet is proof that stellar recycling works, that the remnants of explosions can reorganize into something that not only supports life, but can also understand what it is made of. Understanding that Earth depends on dead stars and is, in essence, recycled stellar residue does not take away its beauty. It adds depth because it turns it into a point where many threads of the cosmos cross and, for a while, take the form of a habitable world. Looking back at everything we have covered so far, it is tempting to think that after traversing galaxies, clusters, and superclusters, returning to Earth feels like coming back to something solid, stable, familiar, almost guaranteed. But in reality, the opposite is true. The more you understand the cosmic context, the clearer it becomes how fragile this planet is and how contingent its history has been. You do not live on a sphere destined from the beginning to host intelligent life. You live on a rock that has survived by sheer luck through a succession of accidents, impacts, climatic changes, and biological crises that, in many cases, came very close to shutting down forever the possibility that you would be here now, listening to this. Imagine Earth's surface not as a fixed backdrop, but as a stage that has changed radically many times. It has gone through eras of suffocating heat and eras of near total cold, through different oceans, atmospheres with compositions that today would be poisonous, continents that have broken apart and come back together, mountain ranges that grew and then eroded until they almost disappeared. Against that geological background, waves of life have appeared that also had their own expansions and collapses, dominations by microbes, explosions of marine diversity, gigantic forests, colossal reptiles, discrete mammals, and only at the very end of all that, a species capable of asking what on earth has happened over the last few billion years. The key word here is contingency. There was no written script saying that, after a certain age, Earth had to produce something like you. What existed were physical and chemical conditions that made it possible for life to arise and evolve, followed by a very long chain of events that could have turned out differently. One of the clearest ways to see this is to think about major impacts. From the beginning, the formation of the solar system was a violent process, with bodies colliding and merging, and the early Earth itself was struck by an object the size of Mars that, according to models, ejected enough material to form the Moon. That impact permanently changed Earth's rotation, axial tilt, and gravitational relationship with its satellite, factors that today influence tides, the stability of the seasons, and climate dynamics. Without that impact, the planet would be different, perhaps habitable, perhaps not, but different. Later on, when life had already been flourishing in the seas and then on land, other impacts marked turning points. The most famous occurred about 66 million years ago, when an asteroid several kilometers in diameter struck what is now the Yucatan Peninsula, releasing an amount of energy far exceeding everything humanity has produced throughout its entire history. The result was a chain of consequences: global fires, dust clouds that darkened the sky, ecosystem collapse, the disappearance of the large non-avian dinosaurs, and of many other species. For much of the biosphere, it was a catastrophe. For the small mammals that managed to survive, it was the beginning of a new opportunity, an ecological opening that would later make possible the expansion of primates and, much later, humans. If that asteroid had arrived a little earlier or a little later, if it had disintegrated in the atmosphere, if its trajectory had been slightly different, dinosaurs might still dominate the planet, and none of your ancestors would ever have had a chance to appear. The fact that you exist today is tied to an impact that had no intention, only an orbit, and that event is just one of many. There have been other mass extinctions caused by abrupt climate changes, gigantic volcanic eruptions, reorganizations of ocean circulation, and internal processes of the Earth that dramatically altered the composition of the atmosphere. At several moments, life came close to being reduced to extremely simple forms that would have taken another eternity to diversify again, if they managed to do so at all. Planetary fragility is not limited to impacts from space. It is also rooted in Earth's own internal dynamics. Plate tectonics, which we now appreciate because it helps recycle nutrients and maintain a relatively stable, long-term climate, is also capable of producing supervolcanoes, massive basalt eruptions, gas releases that alter the greenhouse effect, and sea level changes that submerge or expose entire continents. Cycles of ice and heat, driven by variations in orbit, axial tilt, and the distribution of continents and oceans, have brought the planet several times to the brink of becoming an almost completely frozen snowball Earth, and then back to more temperate states. Each of those transitions has been a severe filter for life, a test it was not guaranteed to pass. When you add all this up, the picture that emerges is of a planet that has spent billions of years walking a tightrope, oscillating between extreme states, taking blows from the outside and shocks from within, and yet maintaining for long enough habitable zones where life could adapt, diversify, and eventually generate consciousness. There is nothing in Earth's size that guarantees this history. It is a medium-sized rocky world, neither small like Mars nor giant like Neptune, with enough mass to retain an atmosphere and liquid water on the surface, yes, but there are many other possible worlds with similar masses where the particular sequence of impacts, eruptions, orbits, and contingencies could have led to very different outcomes. On the scale of exoplanets, Earth is not even particularly remarkable. Current catalogs already list hundreds of rocky worlds in habitable zones around their stars, some a little larger, others a little smaller, some closer in, others farther out. In terms of size and position, Earth is just one case among many. What makes it special is not its radius in kilometers, its exact mass, or its distance from the Sun taken in isolation, but the accumulation of coincidences, a stable and relatively calm type of star, an almost circular orbit that avoids extreme thermal variations, a moderate axial tilt, a large moon that stabilizes that tilt, active tectonics that recycle carbon and regulate climate over long timescales, and a chain of extinctions and opportunities that, by pure chance, led to a species capable of thinking. The word coincidence may sound frivolous, but in this context it is very precise. It does not mean that everything is pure randomness without structure. It means that there is a framework of physical possibilities, and within that framework events have linked together in ways that could have gone differently. There could have been different impacts, different timings for glaciations, different intensities of eruptions, continental configurations, less favorable to biodiversity, local chemical properties that made the emergence of certain molecules less efficient. In many of those other possible paths, life would have taken directions that did not lead to something like you, or perhaps would not have been able to persist for so long in complex forms. Understanding planetary fragility means accepting that Earth is not shielded from drastic change, and that what you perceive as normality is a relatively gentle interval between potential extremes. In the short term, you may have the illusion of stability because decades and centuries are timescales on which the crust does not change much, and the sky seems motionless. But when you widen your view, the crust folds and breaks, oceans rise and fall, climates shift and reverse, asteroids arrive from time to time, and mass extinctions draw a line under entire chapters of the planet's biography. Nothing in that history guarantees continuity forever. And yet, it is precisely this fragility that gives meaning to what you do here. Knowing that Earth is not special because of its size or some cosmic right, but because of the very specific combination of circumstances that have made it suitable for you for a while, changes the way you see it. It stops being a neutral backdrop for your life and becomes a silent protagonist, something that deserves attention and care, because there are no nearby substitutes you can move to if conditions deteriorate too much. From the universe's point of view, losing one more habitable planet does not change the overall balance much. From yours, it changes everything. Returning to the idea that Earth is recycled, stellar residue helps close the circle. This world is not only fragile because of its geological history, but also because it represents a very specific phase in the transformation of matter. Before being a planet, it was a gas cloud enriched by dead stars. Before that, it was primordial hydrogen. Before that, it was pure energy in rapid expansion. Later, billions of years from now, when the sun swells and becomes a red giant, Earth will cease to be habitable and may even cease to exist as you know it. It is in the middle of a process. It is not an eternal object. Thinking about impacts, extinctions, and contingencies should not lead you to paralysis, but to a kind of active humility, knowing that you occupy a world that is not special because of its size, but because of accumulated coincidences, places you in a very specific position. You are the heir to an improbable chain of events, and, at the same time, responsible for what you do during the tiny stretch of time you get to live here. The universe will go on without you. Galaxies will continue on their paths, and dark matter will keep holding together structures you will never see. But in the meantime, on this small and fragile planet, you have the opportunity to be aware of all that and to act as if it matters that this corner remains habitable a little longer. In the end, planetary fragility is not just a physical property of Earth. It is a reminder that nothing you have taken for granted was guaranteed. The fact that there are oceans, a breathable atmosphere, moderate climates, and rich ecosystems is the result of a history that could have broken many times. You are not on a special planet because it is large, bright, or central. You are on a planet that has been lucky and that, for the moment, sustains you. And understanding that, in a universe where most worlds will forever be rocks, ice, or spheres of gas without witnesses, is perhaps one of the deepest ways of valuing the place where you are. After so much time looking outward, it is easy for your mind to grow accustomed to the idea of the immense. Galaxies, clusters, superclusters, cosmic horizons. But now we are going to turn the telescope around and make the reverse journey. Instead of moving farther away, we are going to come closer. We are going to reduce the scale, leave behind light-year distances, and gradually return to the place where you actually are. A specific planet, a specific surface, a specific body. Imagine that you are seeing Earth from afar, as a blue dot spinning in the darkness, and you begin to approach it. First, you recognize the continents, then the clouds, then a particular region, a city, a house, a room, until you arrive at a person sitting or standing, perhaps yourself, listening to these words. All the immensity of the observable universe ultimately flows, in your experience, into that small scene. You here, now, in this corner of the planet. If you keep that zoom going and keep pushing it, the protagonist stops being Earth and becomes you. Your body, which on a human scale seems large and solid, turns into the new planet we are going to talk about. In the same way that Earth's surface has seas, mountains, continents, and an atmosphere, your body has its own landscapes. Skin that protects you like a crust, tissues and organs that resemble internal layers, circulatory systems that function like rivers and roads, lungs where air flows in and out as if they were breathing forests. Most of the time, you do not think of yourself as a landscape. You perceive yourself as a unit, a person, an I. But physically, you are an immense collection of parts, organized into levels that only appear when you change scale. If we could shrink a camera down to the size of a cell and travel through your interior, the world we would see would be as strange as any extraterrestrial landscape. Your blood vessels would be tunnels through which dense currents of red blood cells flow, flexible discs that bend and stretch to pass through the narrowest capillaries. Your lungs would be a forest of branches that split and split again until they end in millions of tiny air sacs, the alveoli, where oxygen jumps into the bloodstream and carbon dioxide makes the return trip. Your intestine would be an endless valley of folds and microvilli that increase the surface area like gigantic cultivated fields, invisible to the naked eye, but essential for absorbing nutrients. None of this is visible from the outside, but it is happening right now as you listen, with a precision you cannot even consciously notice. At a slightly smaller scale, cells become the inhabitants of that inner planet. Each of your cells is like a small city enclosed within a membrane. There is a border that lets some things pass and blocks others. There are internal structures that produce energy, others that manufacture proteins, others that process waste and maintain order. In your skin, your muscles, your liver, your brain, millions of cells work in parallel, responding to chemical and electrical signals, dividing when needed, dying when the time comes. And all of this happens without you having to issue a single conscious command. The I you feel is a kind of emergent level built from the silent work of those trillions of microscopic inhabitants that make up your body. And you are not alone in your own landscape. You share that territory with a huge number of organisms that are not you, but live with you. Bacteria on the skin, in the mouth, in the intestine, microscopic fungi, viruses that come and go. Your body is an ecosystem. Seen at the right scale, it looks more like a planet full of ecological niches than a uniform structure. There are moist places, dry places, nutrient-rich and nutrient-poor areas, regions with more oxygen and less oxygen, and in each of them, different microbial communities thrive that, in many cases, help you digest food, train your immune system, or maintain chemical balance. What is fascinating is that at your mental scale, all of this is reduced to I feel good or I feel bad. Only when you reduce the scale do you see that this well-being is the result of a very complex balance between internal landscapes and their inhabitants. If you keep shrinking the camera, cells stop being the end of the road and themselves become landscapes. Inside a cell, molecules move in an extremely dense watery medium, colliding, binding, separating, following routes defined by the shapes of proteins and by the available energy. What textbooks draw as clean lines between molecules is in reality an ordered chaos of vibrating, bouncing particles in which very precise patterns nevertheless emerge. DNA strands that open and copy themselves, ribosomes that read instructions and assemble amino acids, molecular motors that haul cargo along microscopic roads inside the cell. That constant activity resembles the traffic of a city seen from above, with cars, trains, and pedestrians moving in all directions, except that here the vehicles are molecules and the streets are fibers and membranes. At this point, the scale toward the small begins to show you a curious symmetry with the scale toward the large. Before, we saw galaxies containing stars, which contain planets. Now we see cells containing organelles, which contain molecules, which contain atoms. In one case, you got lost in vastness. In the other, you get lost in detail. In both, your intuition breaks down a bit because you are outside the range where everyday experience works well. You usually think of yourself as something in between, the very large and the very small, with the universe above and atoms below. But when you look at the numbers, you realize that here too, the proportions are extreme. The number of atoms in your body is so enormous that saying it out loud does not help. It is enough to know that there are more of them than there are stars in the galaxy you live in. What is interesting is that this entire microscopic landscape is not something added to your existence. It is what your existence is on the inside. Every thought you have, every memory, every emotion, every time you raise an arm or utter a word is anchored in physical processes at these small scales. Neurons that slightly change their connections, ions crossing membranes, neurotransmitters jumping from one cell to another, proteins being modified. At the human level, you say, I made a decision. At the microscopic level, millions of molecular events have changed state so that that decision can even be formulated. Your body as a microscopic landscape is not just a beautiful image, it is an accurate description. You are, quite literally, a collection of processes at different scales that, organized in a certain way, produce the subjective experience you recognize as I. If you stop to think about it, the same matter that makes up the stars, the matter forged in nuclear furnaces and in supernova explosions, is the matter that now travels through your bloodstream, forms part of your muscles, or supports your bones. The journey toward the small reconnects you with the journey toward the large, but through an intimate shortcut. The carbon that forms your cells was interstellar carbon before it was part of a rock, and before that, it was made in the interior of a star. Now it is here in the form of living tissue that listens and thinks. When you looked at the universe from the outside, Earth seemed like recycled stellar residue. When you look at yourself from the inside, you yourself are that residue reorganized into a microscopic landscape. All of this changes the way you can look at yourself. You stop being only someone who lives on a planet and also become someone who contains a miniature universe of your own, a universe of cells, molecules, and atoms in continuous interaction. What, from the outside, looks like just one body among billions on Earth's surface is, from the inside, a unique structure, with its own history of cell division, growth, illness, repair, and adaptation. And that structure is as delicate as the history of the planet that sustains it. It depends on chemical balances, temperatures, pressures, and energy exchanges that can be altered with relative ease. Looking toward the small scale does not diminish the importance of the large scale. It complements it. The same universe that seemed indifferent to your existence is the one that has allowed this body to exist, with this internal landscape, capable of being aware of its own complexity. You may not be able to travel to other galaxies, but at a conceptual level you can trace the path from the cosmic microwave background to the atoms in your DNA, passing through generations of stars, the formation of the solar system, the history of Earth, and finally the meticulous organization of your own organism. As you continue living your everyday life, these scales coexist within you without your having to think about them. You are at the same time an inhabitant of a fragile planet, part of a galaxy moving through the universe, and the setting for a microscopic landscape in constant activity. You have spent much of the journey looking outward. Now, by looking inward, you discover that the sense of wonder does not diminish, it only changes size.